Hello guys, and hope doing well. Today I finished the ECG project by Arduino. This is my Arduino Mega connected to the LCD and working with 9-volt battery. The battery is AAA 6 batteries, and this is my sensor, 3 sensor, going to connect to the breadboard, and the breadboard is working with IC INA 128. The INA 128 is one of the sensitive operational amplifiers with inverting and non-inverting support, and this is the schematic of the ECG designed by me. You can see the pin number 5 and 8 connected to the pin number 4 and number 7 connected to the positive and negative. Pin 2 and 3 are positive and negative inputs connected over 5 mega ohm potentiometer, this one, to each other, and finally over 104 capacitor connected to the terminal, and the terminal connected to the sensor. This sensor is easy to buy, and also you are able to use the old sensors. If you don't have the sensors, you are able to use aluminum foils and 1 mega ohm resistor. So you can use the aluminum foil and 1 mega ohm resistor if you don't have this kind of sensors. It's easy to buy online, something like 4 bucks. And also I connect the output of the sensors to the project. So this is the compact version of ECG. I did not check anything like this because of the difference of this ECG project is the ADC. I used MCP 3421 as analog input because of the noise levels with the analog input of Arduino. We not let the project to show exact ECG parameters, but you can see connected the project to the MCP 3421, and I used Mega 22560 and 3.2 inch LCD TFT because of I'm going to have the minimum noise with the analog ADC pins over this module, and is very cheap one, something like $2. Oh, online you are able to buy this item, and also this is one of the best and sensitive ADC converters, and going to the Arduino just with 2 wires. You can see this is 2 wires that connected to the Arduino. For the next step of the project, I'm going to change these numbers to the graph or histogram to check exactly the balance and other items for the ECG. And this is the connection that we need. The pin 2 should connect to the right arm. This is my 5 mega ohm potentiometer, and the pin number 2 should be connected to the left arm. The left leg should connect to the ground, but you're able to use the operational amplifier output to ground. If you are using the small batteries, because of the operational amplifier will make strong ground connectivity to the left arm, and also the pulse will come from the left and right arms easier. And I used 1N60. You can use 1N4148 also, or any other germanium diodes to protect noise level. And also INA 121 is the best choice to use the operational amplifier for non-inverting and inverting amplifier mode. So this one you can see is my schematic. It's very simple. It is the most simple project for the ECG I checked before, and this is the best protector and ADC analog digital converter to check the best resolution for the ECG. So you can see the numbers coming. I let the numbers coming one by one in 4 columns and like 20-25 rows to show exactly what's going on, and also I'm able to know exactly 2-3 seconds before refreshing the page what is the ECG numbers. And these sensors should be taped to the left arm, right arm and the legs, and also the left arm and right arm will take the pulse, and also the ground connection will pass exactly the energy outside, and the minimum noise will help the analog converter to detect exactly the ECG pulse. So don't forget to use this analog digital converter, because of, as I told you several times, the Arduino, Uno and Mega, originally the analog digital converters, coming with noise, and to reduce the noise level you should use external circuits using the resistors, using the capacitors, and make short grounds with these capacitors. And I'm not sure finally with this configuration I'm able to have the right and exact noise level parameters number or not. So this is my compact project, and after this I'm going to test with Dr. Hulda Clark Zapper by these electrodes, and we'll make one more video to check the ECG pulse when I'm working with Dr. Clark Zapper. And several times I tried to contact with Dr. Clark to talk a little bit about this project with her, but still no answer from her, and I'm waiting to find her and talk about this project. So finally I will review again the project with you. This is my full schematic of the ECG pulse detector. So I removed this operational amplifier output, and the only ground is good enough to connect to the left arm. Use this side that I make one side here, and also the left arm and right arm should be connected to pin number 2 and 3. And if you are using the sensitive analog digital converter, you can also use the 4.7k ohm resistor. Also I have one more LCD based Arduino. It's made before. It will also show a nice graph of the ECG signals. For the next video I will try to show this and check with hold up Clark Zapper. Thanks for watching this video. Hope to enjoy this compact project ECG and try to find the 5 mega ohm potentiometer like this, and the INA 121 is the best choice to work with ECG pulse. Thanks for watching and goodbye.